So our topic of discussion today is first the basic morphology of liver. Now let's come to the basic morphology of the liver. The liver is the largest gland of the body. It is weighing around 1400 to 1600 grams. This is the cross feature. Now let's get into the microscopic feature of the normal liver first. The liver can be divided into some classical hexagonal kind of lobules. So here are the lobules. Now in the center of the liver there is a central vein like this, the central vein, and in each of the vertex of the hexagon we can create this we can say that these are the portal triad. Now what are the contents of the portal triad? The contents of the portal triad are bile duct first, then this is the hepatic artery, and finally the portal vein. Okay, now from the central vein there are radiating groups of hepatocytes. Of course, in the under the microscope we can't find actually this kind of radiating feature, but yet in the imaginary these are the radiating hepatocytes. In the normal liver, these are apart from the children, these are single cell line plates. Now in children you can find double cell line. In other kind of diseases it can be multiple cell plates also. So normally these are a single plate of cells. Now let's describe the hepatocyte morphology. These are polygonal shaped cells with a nucleus in the center, of course. Now between these hepatocytes there is a bile canaliculus. This is a bile canaliculus. So more of the hepatocytes here, and similarly the bile canaliculi. Now between two rows of hepatocytes now as you can see, between two rows of hepatocyte there is a sinusoidal space. This sinusoidal space is lined by endothelial cell. Now there is a paradox. Now we know endothelium lines blood vessels, but this lining by the endothelium, now this space is not a blood vessel, of course. This is the sinusoidal space. And why this is not a blood vessel? Because there is no basement membrane, only the endothelial cells are there. No basement membrane. So it is not a blood vessel. Now let's come. There are some kind of cells between two endothelial cells. There is a type of specialized cell. This is the Kupffer cell. It is a component of the reticuloendothelial system. Of course, everyone knows what is reticuloendothelial system. Means hepatic macrophage. That is, it belongs to the reticuloendothelial system. Now, the area between a single row of hepatocyte and that of the endothelial cells, this is known as the perisinusoidal space. That was the sinusoid, and this is the perisinusoidal space. This is between the single row of hepatocyte and that of the endothelial cells, also known as the space of Dissay. Now, in this perisinusoidal space, there is a very much important cells. These are known as the ito cells. This lies in the perisinusoidal space. Now this ito cells has got a very important, two important functions in the normal liver. Of course, remember the word, the normal liver, this has got two important functions. These are the storage of fat and storage of vitamin A. So these are the very two important functions, of course, in a normal liver. And why I'm stressing upon this, we'll discuss in our next session, why I'm stressing upon this word, the normal liver. Now, the hexagon, each hexagon can be divided into three zonules. This is the zone 1, means the now the zone surrounding the central vein, it is the zone 3. Now next to the zone 3, it is the zone 2. Now the final zone at the periphery, It is the zone 1. Now there are certain importances of this zone. Since the zone 3 receives the most of the blood supply, so of course in case of any kind of congestion like the chronic venous congestion, the zone 3 is going to be the most affected. And in the zone 1, since it receives the arterial blood supply by the hepatic artery, so directly the toxins we receive in case of any kind of poisoning is going to enter through this zone 1. So this will going to affect this periportal area, means the zone 1. So remember that zone 3 is going to be affected in any kind of venous congestion, in any kind of lack of blood supply, and the zone 1 is to be affected in any kind of toxic injury. So here lies the importance of all these zones. Now let's come back to the function of this bile canalicula's. The bilirubin conjugation occurs in the hepatocytes. Now after its conjugation, it has to travel to the main bile ducts. So there comes the importance of this bile canalicula's. Through this bile canalicula's, the bilirubin enters here and then to the main bile system. So if any kind of obstruction is here, then it can lead to predominantly conjugated hyperbilirubinemia. This we will discuss in our next subsequent sessions. Okay, thank you.